Since you know a little bit about SOHCAHTOA now, I'm going to show you how to use it. Okay? Now the primary trig ratios are referring to these three fractions: sine, which is opposite over hypotenuse; cos, which equals to adjacent over hypotenuse; and tan, which is opposite over adjacent. These three fractions are also ratios. Okay? So what I need you to do is take out your calculator and make sure that this is on degrees. Okay, it'll say D. If it says R, it's probably on radians, which means that you're going to get incorrect answers. So you want to make sure it's on degrees first and just change it. All right, I'm going to show you how to use your calculator for trig. When it says tan 30 degrees, it basically means tan theta when theta is 30 degrees. So my angle is 30 degrees. I want to know what that equals to. In other words, I want to know what this fraction equals to. Okay, and it's very simple. All you're going to do is you're going to go to your calculator, you're going to select tan, and then you're going to press 30. So I'm getting something like this: 0.5773, and so on. Okay, so a big number with lots of decimal places. They want you to round to the nearest thousandth. This one's the tenths, hundredths, and thousandths. So I want to stop at three numbers after the decimal place, but we always want to look at that fourth and see if that's going to round up our 7. Now, since a 3 is quite low, our 7's probably going to remain the same. So there you go, that's our answer, and we've rounded, so approximation dot. Okay, this answer basically means this is your ratio of your opposite over your adjacent. Okay, let's try the next one. So again, all you're going to do is you're going to press sine, you're going to type in 75, and you're going to get a decimal place, again, 0.96592 dot dot dot. Okay, and again, we want three numbers after the decimal place, but we're always looking at that fourth to see if it's going to round our 5 up, and it does. So 9's a little bit high. I'm going to change that 5. It's going to round up to a 6. Okay, an approximation because I rounded. And again, this answer represents opposite over hypotenuse when your theta was 75 degrees. Okay, let's try the last one. So you're getting the hang of this now. Cos 180, press equals. Oh, well, that's just -1. Well, that was convenient. Okay, no approximation dot because you didn't actually round at all. Okay, why don't we try something else? What I'm going to do this time is I'm going to give you the decimal, but I'm not going to give you theta. And notice that sometimes theta can be represented by a letter. So this theta, they're all the same. Okay, they represent angles. We're going to go backwards now. We're going to give you the answer, which is a decimal, and I want you to go backwards and find the angle. Okay, and it's actually very straightforward. It's kind of almost like solving. All right, I want A by itself. I want to know what angle A is. So I'm going to get A by itself if I take tan to the other side. So it's kind of like solving an equation. But when you take tan to the other side, it's going to change. It's going to change into the opposite, and that's this guy. Now the -1 means inverse, so this is the inverse of tan. In other words, the opposite of tan. And you're just going to put the number, 782. Okay? Since we're looking for an angle, I want you to put the angle symbol. This is important. That's what I look for when I'm doing communication marks. Okay, so the angle symbol looks like an L but very sharp. How do we put this into our calculators? Okay, what you're going to do is to get that -1 with the tan, you're going to press shift. Your calculator might also say second. Okay, and then you're going to press tan. So that's kind of like the opposite of doing tan. And then you're going to press 1.782 and equals. So shift tan 1.782. And I'm getting to the nearest degree, so that's no decimal places, angle A is approximately 61. And don't forget your degree sign. It's just like a centimeters. You need to add your units in. Okay? Let's try the next one. Again, I want theta by itself. So I'm going to bring sine over to the other side. And I'm going to write the inverse of sine and then the 1/2. Okay, so we're going to press shift and then we're going to press sine and then 1/2 or 1 divided by 2. You might have to close the bracket. And I got exactly 30 degrees, so no approximation dot. You'll notice that I didn't put an angle symbol for theta. Theta represents an angle. A might not. A could represent just, say, if it was a triangle, it could represent this angle, in which case I would put an angle symbol, or it could represent a coordinate. I'm not sure. So in that case, I would put an angle symbol to tell them I actually mean that this is what I found, not this. Okay? Theta, on the other hand, always represents an angle, and that's why I don't have to put the angle symbol. All right, one more. Let's find x, bring it to the other side. Angle x equals to cos inverse 0.7431. Okay, so shift cos 0.7431, and that equals to approximately 42 degrees. Okay, so I've showed you several things. I've showed you how to find the primary trig ratios. I've showed you how to find angles now. The last thing I'm going to do is I'm going to show you how to find the angles with a diagram this time. All right, so I have triangle ABC. Notice that they told you what little a was. So again, little a is the opposite of big A. And they also told us what little c was, which is the opposite of big C. Okay? So just wanted to remind you that was from the similar triangles tutorial. All right, so you're looking for the angle and you want to find angle A. That means that my eyeball, since I'm looking for this one, I'm going to draw my eyeball right here. That means that this is my opposite side, this is my hypotenuse, and this one is my adjacent. Okay, because I'm looking for angle A right now. All right, now that I have all the sides labeled, I'm noticing that one of them is pretty useless. It doesn't have a number with it. Opposite is 13, adjacent is 11, but hypotenuse has nothing there. So we don't even need it. Let's just erase that. It's useless. Okay? What I want to do is I want to use opposite and adjacent, and I'm going to take a look at my SOHCAHTOA, okay? And I'm going to see which one uses opposite and adjacent. All right, and that looks like, oh, what do you know? Opposite and adjacent. That's tan. I have to use tan. Okay, so I'm actually going to use tan to figure out my answer. Let's write down the tan formula. Tan theta is opposite over the adjacent. TOA, right? TOA? Now I'm going to fill in everything that I know. So tan theta in this case is your A. Opposite is 13. Your adjacent is 11. And all of a sudden, this question, this step right here, looks very similar to one that we just did, these guys over here. So what I'm going to have to do is I'm going to have to do the opposite. Remember, bringing the tan over to the other side. All right, so let's do that. Okay, I'm going to bring tan over to the other side. Angle A is equal to tan negative 1, 13 over 11. Okay, remember to press that shift button, shift tan, and then 13 divided by 11, close your bracket. And I got angle A as 50 approximately. Okay, so approximately 50 degrees. And I rounded to the nearest degree. That means no decimal places. All right, let's get rid of all this. Now that I've solved one, I'm going to solve the other. Let's look for angle C. That means I'm looking for this angle this time. My eyeball is going to be down here. That indicates that this side is my opposite this time. This side is my hypotenuse, and this side is my adjacent. We're going to go through the same steps. I'm noticing that I have an 11 and a 13 for opposite and adjacent, but again, that hypotenuse is kind of useless. There's no number there. We can get rid of that. We don't really need that. Okay, so we're going to go back to the first slide and see, well, what uses opposite and adjacent? Isn't that this one again? Opposite and adjacent? So we're using tan again. All right, tan theta is opposite over adjacent. I think you're starting to catch on. If I actually needed my hypotenuse, then I'd be using a different trig ratio. Okay, let's start filling everything in. So your theta this time is C, tan, and then angle C, equals to your opposite, which is 11, over your adjacent, which is 13. Okay, and again, I want C by itself, so I'm going to move tan to the other side. Angle C is equal to tan negative 1, 11 over 13. And just punch it into your calculator. So shift tan 11 divided by 13, close your bracket, and I'm getting angle C is equal to 40 degrees approximately. All right, since it's a word problem, you probably want to put a therefore. Therefore, angle A is 50 degrees and angle C is 40 degrees. That kind of makes sense actually if you just think about it. If everything inside the triangle should add up to 180 and this one is 90 already, shouldn't this one be 40 and 50? Those add up to 180. Yeah, these two make 90 and that one makes another 90. Okay, so it does actually make sense. So I'm hoping that you enjoyed this tutorial. It's a little bit long, I know, but it's the start of trig. So we'll be learning about how to find side lengths next. Until next time.